Okay, so a very good morning to all of good afternoon to all of you. Now I'm going to start today's session. So before going details about today's session, I'll discuss what we discussed in the previous class. Okay, so in the previous class we discussed about the circular convolution, how we can find out the circular convolution between two sequences. Okay, so using different methods. First is general method we discussed. After that, concentric circle method, that also we can say graphical method in case of circular convolution, and the last one we'll discuss about matrix method. Okay, so these methods we discussed in the previous class. So how we can find out the circular convolution. Okay, so anyone any doubt what we discussed in the previous class about the circular convolution? So any doubt in any problem? So we'll discuss that. Otherwise, we'll move to the next part of our discussion. Anyone any doubt?
No, sir.
Okay.
No, sir.
Okay, now I'm moving to the next part of our discussion. Okay, anyone want to ask anything? Okay, so I'll move to the next part of our discussion. So what is the next part of our discussion? Listen carefully. Already we discussed the property of DFT, that is the circular convolution. So what is that property? When x1 of n circular convolved with x2 of n, when we'll find out its DFT, so the DFT is the product of its corresponding input sequences. That is, if x1 of n circular convolved with x2 of n, then what is its endpoint DFT? So DFT endpoint, that is x1 of k into x2 of k, product of its DFTs. Okay, this is the property of circular convolution. That is one property of DFT. Clear? Now already we find out the circular convolution using general method, concentric circle method, as well as matrix method. Now I am going to show you how we can use the property of this DFT of circular convolution to find out the value of x3 of m, that is the circular convolution. Okay, listen carefully. Now I have to find out the circular convolution using the property, that is the property of DFT, one property of DFT. Okay, so that property already I wrote here. Okay, so I'm taking this question. Based upon this question, I'll discuss. Okay. So now find the circular convolution of two sequences. X1 of n is equal to 2, 1, 2, 1, and x2 of n is equal to 1, 2, 3, 4. So based upon this problem and using this property, now I am to find out. Okay. So what is this property? So first what you have to do? X1 of n is given, x2 of n is given. So what you have to do first? You have to first find out x1 of k, then x2 of k, because then you have to product it. So after the product, whatever the value will get, this is a third DFT, that is x3 of k. So when we will find out its IDFT, then we will get its corresponding time domain signal or sequence, that is x3 of n. That is the property already discussed previously. Now we have to use this property to find out the value of the circular convolution, that is x3 of m. Okay, now for that already I wrote what are the given data in the question. That is, first you have to write the given data in the question, that is x1 of n, which is equal to 2, 1, 2, 1, x2 of n is equal to 1, 2, 3, 4, then n is equal to 4, and here what is the value of small n? 0 to n minus 1, that is n is 4, so 4 minus 1, 3, that is 0, 1, 2, 3, the small value, the value of small n. Okay, now here already I calculated. So listen carefully. So first what you have to do? First you have to find out the value of x1 of k. So the 4-point DFT of x1 of k, because the value of n is 4 capital N. So you have to calculate the 4-point DFT. Okay. So first that already we calculated. So here you have to calculate. So x1 of k, which is equal to summation n is equal to 0 to 3 x1 of n into e to the power minus j 2 pi kn whole divided by 4. The formula directly you can find out because already we practiced so many problems previously regarding DFT. Now, so individually now you have to substitute the value of n is equal to 0 to 3 for each value of k. Okay, that already we discussed. So now, so first we have to calculate what is the first value 2 plus e to the minus j pi k by 2 plus here directly I substitute the value of n. Later I will substitute the individual value of k. Okay, so either way you can calculate. You can take individual value that already you discussed. Otherwise you can expand this summation first, then substitute each individual value of k. You will get the value of x1 of k. Okay, now 2 plus e to the minus j pi by 2 pi k by 2 plus 2 into e to the minus j pi k plus e to the power minus j 3 pi k by 2. Now first you substitute k is equal to 0, you will get x1 of 0. So k is equal to 0 means, so this is 1, this is 1, this is 1. So 2 plus 1 3, then 2, so we'll get 6. So here x1 of k is equal to 6. Clear? Now the next one, x1 of 1. So you have to substitute the value of k is equal to 1. So in this, when you substitute k is equal to 1, 2 is fixed. No value of k is here. So 2 plus e to the minus j pi by 2. So e to the minus j pi by 2 is. So e to the minus j pi by 2. What is the value of e to the minus j pi by 2? Anyone? Hello?
Minus.
Am I audible? So what is the value of e to the minus j pi by 2? Respond anyone? Mansa?
Minus j, sir.
Minus j, sir.
Minus j. Okay. Okay, very good. So the value is minus j. So here I'm going to write. So 2 minus j. So then plus 2 into e to the minus j pi k. So what is this value? Minus 2. Because e to the power minus pi minus j pi is minus 1. So this is 2 into minus 1 minus 2. Then plus e to the minus j 3 pi by 2. 3 pi by 2 is e to the minus j 3 pi by 2 is j plus j. Okay, so 2 plus 2 minus 2 is plus j minus j. So this is 0. Okay, so the value will get x1 of 0 is equal to 0. Now you have to calculate because already we practiced so many problems regarding this. So again I am explaining this one. So the next x2 of k you have to calculate. Okay, now when you substitute k is equal to 2. So when k is equal to 2, this is u to the minus pi e to the minus j pi. So here this is 2 into e to the minus j 2 pi. So this is e to the minus j. So 2 to cancel minus 3 pi. So the value will get 1 because all the value whatever you will get plus minus cancel. So only the value remaining is 2. Okay. So the x1 of 2 is equal to 2. Then in the same manner x1 of 3 is equal to will get 0. So this is the value of x1 of k, individual value for k, that is x1 of 0, x1 of 1, x1 of 2, x1 of 3. Okay, in the same manner we have to calculate again the 4-point DFT of x2 of n. So that is x2 of k, so which is equal to summation n is equal to 0 to 3 x2 of n e to the minus j 2 pi k n whole divided by 4. So which is equal to summation n is equal to 0 to 3 x2 of n e to the minus j pi k n by 2. Okay, so now individually you find out the value, substituting the value of n is equal to 0 1 2 3, expand this summation. Now individual value we have to substitute. K is equal to 0, then k is equal to 1, k is equal to 2, then k is equal to 3. So we'll get x2 of 0, then x2 of 1, x2 of 2, x2 of 3. That already for 1 2 3 4 already calculated. 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Okay, this is the DFT of x2 of n sequence. Okay, now what is the property? You have to product. So individually you have to product. So you have to product the two sequences, that is x1 of k and x2 of k, that is 4 point DFTs of x1 of n and x2 of n. So x3 of k, which is equal to x1 of k into x2 of k. Clear? Now, so here for your reference, I am writing again x1 of 0 is equal to 6, x1 of 1 is equal to 0. So that what already we calculated here, that only I am writing here. Okay, x1 of 2 is equal to 2, x1 of 3 is equal to 0. Then x2 of 0 is equal to 10, x2 of 1 is equal to minus 2 plus 2j, x2 of 2 is equal to minus 2, x2 of 3 is equal to minus 2 minus 2j. Okay, now you have to product. So product means you have to individually product. So x1 of 0 into x2 of 0, that is 6 into 10, that is 60. Then x1 of 1 into x2 of 1, that is 0, 0 into something is 0. Then x1 of 2 into x2 of 2, that is you will get 2 into minus 2, that is minus 4. x1 of 3 into x2 of 3, that is 0. Okay, so this is the value of x3 of k, that is x3 of 0, x3 of 1, x3 of 2, x3 of 4. Directly you will get byproduct of the two DFTs. Okay, now this is x3 of k. So now what is the value of x3 of k? So individual directly if you write 60, 0, minus 4, 0. This is x3 of k. Now what you have to do? When you will find out the IDFT of x3 of k, you will get the value of one other sequence, that is x3 of m, that is the circular convolution, okay, of x1 of n with a circular convoluted x2 of n. Okay, so what is the formula for IDFT? That already we discussed. 1 divided by capital N summation n is equal to summation. Okay, so this value is k. So summation k is equal to 0 to 3. So k is equal to 0 to 3 x3 of k e to the minus j 2 pi k n whole divided by 4. So which is equal to, so here the value of capital N is 4. Okay, so 1 by 4 the summation formula you can write, and the value of n is 0, 1, 2, 3. Okay, so now in the same manner if we will expand this summation, so 1 by 4, 60 minus 4, because two values are 0. So 60, this is the first value 60. Then the third value is minus 4. Third value is k is equal to 2. So k is equal to 2. So 4 into e to the power j pi k. Clear? So this is the value of x3 of n. Now you have to substitute n is equal to 0. You will get the first value. When n is equal to 0, so 1 by 4, 60 minus 4. So this is e to the power 0 means 1. So 60 minus 4, that is 56, divided by 4, that is 14. So x3 of 0 is equal to 14. Okay, then what is the second value? When you substitute n is equal to 1, when n is equal to 1, e to the power j pi 1, so that means e to the j pi, j pi is, that is minus 1. So minus 1 means this is minus 4 into minus 1, that is 4. So 60 plus 4 divided by 4, that is 16. Second value. Okay, in the same manner when we substitute 2, so the value is, so it was j 2 pi, that means 1. So again we will get 14. Okay, now what is the next one? So 1 by 4, 16, that is 3, we will get 16. So the value of x3 of m, which is equal to 14, 16, 14, 16. Okay, you can verify. Previously we solved this problem using general method as well as concentric circle method as well as matrix method. You can verify your answer. You will get the same answer because we are using different methods, but the output or result must be same. Okay, so x3 of m is equal to 14, 16, 14, 16. This is the circular convolution of x1 of n with x2 of n. Okay, so this is the circular convolution using the property of circular convolution, that is the property of DFT. Okay, I hope all of you understood this. How many of you understood this? Write down in the chat box. After that, I'll move to the next part of our discussion. So how many of you understood this property, using this property to find out a circular convolution? Write down in the chat box. So those who are not understood, write down not understood. I'll again explain. Okay. So those who are understood, write only understood. Those are not understood, write on not understood. I'll again explain. Those who are not understood. Okay. I want all of you have to respond. Okay. So from your respond, what I understood, all of you understood this. Okay. So very good. Now, so what to do? So I'll give another problem. Try to solve this problem by yourself. So whichever method you can use, no problem. Okay, it's up to you. So we discussed how many methods to find out the circular convolution. Four methods. First one is general method. Directly you can expand the formula. What is the formula for circular convolution? You can substitute the values individually, values of n and m, then you can get the output. This is general method. Then next is concentric circle method or graphical method. Third one is matrix method. Okay, then the next one you are using the property of DFT for circular convolution to find out the circular convolution. Okay, so four methods we discussed how we can find out the circular convolution. Now I'll give another problem. For this problem, all of you solve this problem and write your answer in the chat box. Okay, so whichever method you are comfortable, you can use, no problem. But whenever the question comes in the exam, you have to read carefully the question, which method it asked. Based upon that method, you can proceed. Okay, but here, whatever I'll give the question, whichever method you can use, it's up to you now. But you have to practice all the four methods. Okay, so write down this question. Find the circular convolution of two sequences x1 of n is equal to 1, comma minus 1, comma minus 2, comma 3, comma 1, and x2 of n is equal to 1, 2, 3. Okay, so find out the circular convolution of two sequences. X1 of n is given 1, minus 1, minus 2, 3, 1, and x2 of n is equal to 1, 2, 3. Okay, so I will give you 5 minutes. So by that time you can simplify. Whichever method you can use, it's up to you. You can use the general method, or you can use the concentric circle method, or you can use the matrix method, or you can use the property of DFT. So whichever method you are comfortable, solve and write your answer in the chat box. I'll see there your answers. After that, I'll discuss this problem. Then we'll move to the next part of the discussion. Okay, next property of DFT.
Sir, once again repeat the question.
Okay, so write down the question. Find the circular convolution of two sequences. Find the circular convolution of two sequences. X1 of n is equal to 1, comma minus 1, comma minus 2, comma 3, comma 1, and x2 of n is equal to 1, comma 2, comma 3. It is okay?
Okay, sir.
Okay. Okay, so Lahari wrote the answer is 12, 4, minus 1, minus 4, 1. Okay, I hope this is the correct answer. Madhuri also wrote 12, 4, minus 1, minus 4, 1. Okay, so Lahari, which method you are using?
Matrix method, sir.
Okay, okay, no problem. Harshita P also wrote 12, 4, minus 1, minus 4, 1. Okay, the answer is correct. So Kausalya also wrote the same answer. Okay, also you will get the correct answer. Okay, Mansa also wrote the same. Hemant Reddy also got the same answer. Okay, it's very good. All of you got the correct answer. Now, so okay, so others also respond. Okay, Nandini as well as this Charisma. Then Kalyani. Okay, all of you got the correct answer. Okay, very good. Now, my question is next. This question is for your homework. Okay, so this question is for your homework. Write down the homework question. Find the circular convolution of two sequences x1 of n is equal to 1, minus 1, minus 2, 3, 1 and x2 of n is equal to 1, 2, 3 using concentric circle method. Okay, using concentric circle method. This is for your homework. Find the circular convolution of two sequences x1 of n is equal to 1, minus 1, minus 2, 3, 1 and x2 of n is equal to 1, 2, 3 using concentric circle method. Okay, so all of you write down, this is the homework question. You have to solve and send back to my mail ID. Okay, I'll check there. Okay, am I audible?
Yes, sir.
Okay. Okay, now I'm moving to the next part of the discussion, that is called the next property of DFT. So what is the next property of the DFT? That is called time reversal of a sequence. That already we discussed this property in DFT, time reversal property of the DFT. So what is this property? Listen carefully here. So if x1 of n, okay, so here just you have to modify. So if x of n DFT is x of k, that is its endpoint DFT. So endpoint DFT is x of k, then x of minus n, that is what we can pronounce x of minus n modulo n. Okay, so that means what is this value that already we
Like,
discussed in previous class, x of capital N minus n. Okay,
sir, screen not
anyone?
visible.
Okay, 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 just wait. Okay, okay, now it is visible.
Yes,
Yes,
sir.
sir.
Okay, 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 so if x of n, n point DFT is x of k, then x of minus n modulo n. Okay, this is the pronunciation. What is this value? X of capital N minus n, that we discussed in the previous class. How we will calculate this value? Okay, x of n minus n. So when we will find out its DFT, that is called time reversal. We will reverse the time. What is the meaning of time reversal? N must be replaced by minus n. This is time reversal. But in case of DFT, when we will make its time reversal, how will get this? So modulo n. x of minus n modulo n. The value is x of capital N minus small n. Okay, x of n minus n. So what is its endpoint DFT? So its endpoint DFT is capital X of minus k modulo n. Okay, so that means capital X of n minus k. This is the property. Okay, so you can prove, you can do the proof. So now I'll give this question. So now we can solve, prove it, because this property, every property has proof. Okay, so this time reversal property proof. Now we can do it. So if you can able to do, it's very good. Otherwise I'll discuss, no problem. But I want you have to try first. Okay, so first you have to try, then I am going to discuss this property proof. Okay, then the remaining properties, the proof, I will discuss the properties. The proof will you can verify by yourself. Okay, so if you have doubt in any property, you just ask me the question, I will explain that one at that time. Okay, so now what is the proof of this property? So here I am going to write this proof. So listen carefully. So what you have to do? You have to find out the DFT of x of minus n modulo n. So that means what you can write, DFT of x of minus n modulo n. Clear? Modulo n. So what you have to do? So this is DFT of x of capital N minus small n. Okay? DFT of capital N minus small n. How we'll find out this value? Okay, so how we'll find out this value? So already you know what is the DFT of x of n. What is the DFT of x of n? That is x of k. So which is summation n is equal to 0 to, this is n minus 1, n minus 1 x of n e to the power minus j 2 pi kn whole divided by n. Okay, and the value here, the value of k is 0 to n minus 1. Okay, so now, so what do you have to find out? DFT of x of n minus n. Okay, so n minus, so how will find out this value? So this is DFT of x of n minus n. Okay, so now here for your understanding, I'll change this variable, because both only the variable change. So n minus m. Okay, so n minus m. So what is this value? So summation m is equal to 0 to n minus 1 into x of m whole into e to the power minus j 2 pi k n minus m whole divided by n. Clear? Now what is this value? So summation m is equal to 0 to n minus 1 x of m e to the power minus j 2 pi k 2 pi k n minus, okay, so here I will write, so minus j 2 pi k m whole divided by n. So what is this value? So summation m is equal to 0 to n minus 1 x of m e to the power minus j 2 pi k into e to the power minus j 2 pi k m whole divided by n. So what is this value? E to the power minus j 2 pi k. So the value is 1. So this summation, so m is equal to 0 to n minus 1 x of m d to the power minus j 2 pi km whole divided by capital N. Okay, so capital M. So now what is this value? So this value is, this is x of m. So this is what we can write, the value what we can write this value. So okay, so summation we can write m is equal to 0 to n minus 1 x of m. This we can write as, listen carefully, minus j 2 pi m. In place of k, what we can write, n minus k we can write whole divided by n. So this is equal to x of n minus k. So e to the power, this is e to the power here only km. So in place of k, what we can write, n minus k, because e to the power j 2 pi k, which is equal to 1. So if it will write it was a 2 pi 1, so we can write this as x of n minus k. So the dft of x of n minus n, that is minus n modulo n, the value is x of n minus k. So this is the proof of this dft. Okay, so I hope all of you understood this proof of this property. So try to understand the property, the time reversal. When we reverse the time in the time axis, that is n is replaced by minus n, then what is its dft? N point dft, that is x of n minus k. Simple. Okay, so this is the time reversal property of a sequence of DFT. Okay, now the next one is circular time shift of a sequence. Next property, circular time shift of a sequence. So what is this property? If x of n, n point DFT is x of k, then so circular time shift, that means you have to shift the time. So previous one is reversal. So here time shift, circular time shift, that means n minus 1. Okay, if this is not n minus 1, this is n minus l. So for your understanding, this is l. So n minus l modulo n. So that is you are shifting in time. Okay, that is circular time shift, because here n minus l modulo n. What is its n point dft? Its n point dft is x of k into e to the power, what is the part here, l, that is e to the minus j 2 pi k l whole divided by n. Because this property is called in time shifting property of DFT. So what is that property? X of n minus k. That property, that means e to the minus j 2 pi k, e to the minus j omega, e to the minus j omega k only comes into the part, and another is x of omega. Here x of k into e to the minus j 2 pi k l whole divided by capital N. This is the circular time shift. If you will shift in time, then what is the value of the n point dft? Okay, if you know the dft of x of n, that is x of k, then x of n minus n modulo n dft is x of k into e to the minus j 2 pi kl whole divided by n. Okay, so the proof of this you can I hope you can do by yourself. Okay, now I'll give you 2 minutes. You can prove this property. Okay, so after the proof, you share your screenshot in the chat box. I'll verify your answers there. Then I'll discuss. Okay, so all of you shall prove this property. So when x of n dft is n point dft is x of k, then what is the dft of x of n minus l modulo n? The dft is x of k into e to the power minus j 2 pi k l whole divided by n. So all of us, hello. Anyone want to ask any question?